So see here in this, okay. So what we have done here, I wanted to identify the maximum and minimum. Hence before you can see, without using max and minimum, without using divide and conquer, I created. But now what we are doing here, uh, with divide and conquer, I am doing with divide and conquer. So what is this exactly? It is nothing but I is equal to j. You can see this one, I is equal to j is nothing but it's a small problem. It's a small problem actually. So like this, there is a only one array, simple array like this, only one array, that is a having some value 10, index is 1, like this. If this is the case, what is that case? Index, starting index also 1, ending index also 1, right? So this is the case, 1 equal to 1 is nothing but what? Maximum is equal to minimum is equal to a of I is nothing but what exactly? That is 10. This is the maximum as well as this is the minimum. Now max also it will going to return 10. Again minimum also it will go to return 10. Fine. Now see here. So that is the case. Again, if come to the second case, again, if like this, suppose think like that, we have an array and having two elements like this, 1 and 2. So starting index is 1, ending index is 2. Think like that, we have a elements like year 5, year 25. Okay, now what I will going to do, just I will going to put the condition I value is what right now 1. Okay, that is equal to j value, I have to give it 2. So that's why I is equal to j. It's not at all possible. Please understand, it is not at all possible. Just I wanted to make condition true. So that's why what I will going to do, j minus 1 I will do. Now the condition will become true. Correct? Correct or not? Now the condition will become true. So hence the condition is true. What I will going to do here, I will going to create a condition, one more condition here. If a, see here, a of I is nothing but what? 5. That is what? A of I is nothing but what? That is 5. 5 is greater than or greater than a of j. A of j is nothing but what? See here, everybody observe here. A of j is nothing but what? 25. Check it. Here 5 is there, 25 is there. Okay. 5 is greater than 25. Is it true or false? Actually false. Correct or not? Actually false. That's the reason why what I will going to do. I will go to the else part. See here. I will go to the else part. I will going to write like this. Max. Okay. Max is equal to a of j. Yes or not? Correct or not? Because here 5 is greater than 25. False. That's why I'm going to the else part. I'm saying that j is true. J is greater. That's why max is equal to a of j. Again, I will say again, min is equal to minimum is equal to a of I. Correct? A of I. Correct. Perfect. And in this case, suppose think like that here 115 is there. 115 is there. 115 is greater than 25. That is true. We know that that is true or not true. So that's why what I will go to do, hence it is a true. That's why I will go to say max is equal to, okay, a of I. Again, min is equal to a of j. That's it. Correct or not? Correct or not? Clear? So that's it. Over. For this condition, over. I think it's finished. No problem here. Suppose these two conditions are okay. This is also small problem. This is also small problem. Okay, that is fine. Suppose if it is a big problem like this, think like that. If it is a big problem like this, a 1, 2, 3, 4, 5 like that. So many indexes are there. 1, 2, 3, 4, 5 like that. So many indexes are there. So this time what to do? So that's why we're going to use else part. We're going to use the else part. Getting everyone? Please message me. Getting everyone? Somebody said it's difficult to understand. Now okay? Getting? Hello? Please tell me. Yeah, okay, fine. Now what is that? It is a big one. Okay. So it's a big problem. You can see this is a big problem. So we have index 1, 2, 3, 4, 5. It's a big problem. Now what we have to do, basically in the divide and conquer, what we're going to do, we're going to divide an array into two parts. That is what exactly we will do. So that's why what I will going to do, I will divide like this. I value is initial value, this is I value, here I value, here j value. Okay now, I plus j, okay, divide by 2. What is the I value? Tell me what is the I value? I value is equal to 1 plus, what is the j? See here, what is the j? J is 5. Clear everybody? J is 5. Everybody clear? 1 plus 5, that is equal to 6. 6 divided by 2. What is the value? 3. Nothing but up to here division is happened. This is the midpoint, you got it. That is what exactly I did it. And I made a small mistake. I will show you that one. Just a moment. What mistake I did it. Okay. Now, no mistake actually. It's just notation missing. So what I'm taking here, I'm taking a floor value. Please understand, I'm taking a floor value. When you're writing a program, please everybody observe here, when you're writing a program, suppose think like that, when you're writing a program, what it says that very clearly, suppose integer, okay, you write like this, 2.5. So what it will going to consider? It will going to consider 2 round figure. Okay, it will going to make it round up. If you got anything, something like that, 2.5, something like that, it will take the floor value, nothing but 2. Here we are getting exact value, no problem. 1 plus 5, 6, 6 divided by 2, 3 we are getting, no problem. Okay, if you are getting any floor value like this, you can do that. So here we are not getting any floor value, that is okay, no problem. So that's why I'm doing this. Okay, so what we're going to do for this is the mid actually we are getting. That's it, very simple. I value is starting index, j value is ending index. Again divide by 2. That's it, very simple. No need to worry. No need to worry for this. Fine. Now, okay, so we divided 2. So this is comes under left side. I will going to say this one as maximum 1. This side, whatever the values you will going to get, that is maximum 1. So this is, sorry, minimum 1. Okay, now this side. Here also I will going to say maximum 2, again minimum 2. This side, whatever the things it will come, this is minimum 2. Now what I will going to do, still I have to divide this array or not? Okay, still have to divide this array. 1 2 is okay. For those reasons we have written a program. For 1, if it is index 1, okay, no problem, it will terminate here. If index is 2, it will going to terminate here. But see here, index is 3 here. Yes or not? Again I have to divide or not? That is the reason why what we will going to do, we will going to apply the recursion here. So we will going to apply the recursion. What I will going to do, basically max 1 comma max, sorry, not max, that is actually min. Sorry for this, min 1, max 1 and min 1, that is equal to, see here. So what we have taken the function divide and conquer max and min, divide and conquer DAC max and min. This is the function. Okay, so what I will going to do, basically we have divided here. Okay, we have an array, that is the array A. Okay, no problem. Again index starts from I, we know that. Okay, I, that is also fine. Again where it is ending at mid here, correct or not? We got the mid element, that is 3. So here it is the mid. Okay, this is the mid. This is the mid we are getting. So that is fine. That is the reason why what I will going to do, up to mid. Fine, that's it. I think okay, everyone okay now. Again one more, this is okay, this is fine. Again come to this side, see here, now max 2 min 2. Okay, now see here, that is equal to, now max min. So what is the array? Same array. Okay, where it is starting from where? Mid plus 1, up to here over already, mid plus 1. Okay, nothing but this one, mid plus 1, mid plus 1. Again where it is ending, j here, j, that's it. Okay, so this is your recursion, nothing but conquer, it will going to happen here. Division, it will going to happen here. here conquer, nothing but process it will going to happen, nothing but up to here. So what, again if I divide this one, what happens here? So 1 plus 3 divided by 2, again 1.5 something, you will going to get it 1, like that. So like that, again recursion it will going to happen for this particular one, again and again recursion will going to happen. So that is one thing. Again finally, if I have to combine, right? After getting those things, after, see here I will going to get the value, yes or not, because it will going to end up in this condition, it will going to end up at this condition. Here if I divided, again it will be divided, again it will going to end up with these two conditions. So that is the reason why what I will going to do, if max 1 greater than max 2. Okay, so then what we will going to do, max 1 is greater than max 2 is nothing but then max 1 is the max. Okay, that's why max is equal to max 1, max 1. Otherwise, else max 2. Max is equal to max 2. That's it. Very simple actually. If I written for max 1, I will going to write for minimum. Minimum 1 is greater than minimum 2. Nothing but two combinations you got it. So max you will going to compare, again you will going to combine. Again minimum you will going to compare. So you will going to get the minimum. That is equal to, write down, that is equal to min. Okay, so that is equal to min 2 else min 1 is equal to min 1. That's it. Okay, now. So nothing but what exactly? Minimum is minimum 1 is greater than minimum 2. Nothing but what? So minimum 1 is greater than minimum 2, which is the minimum now. Then minimum 2 is the minimum. Okay, minimum is over. Again, next one, else minimum 1 is the minimum. That is what exactly we did it. Finally, what I will going to do? Return what I will get? Maximum, okay, as well as minimum. So this is what exactly I told you. Okay, this is for one scenario, this is for two scenario, for terminating conditions, this is for big problem. Like that we will going to deal here. Now close this one. Okay, so here we open, right? Up to here, it's over. Correct or not? Again we opened here, again close here also. So that's it. So this is your small program. Okay, now observe here. Here everybody please observe. Everybody please observe now. Okay, some people are still they are having doubts on this. See here, how many times it will going to execute. Everybody observe please. Here, this one, how many times it will going to execute? Only one time. See here, only one condition. If it is true, over. Maximum minimum you will going to get it. Here only one comparison, here no comparison. So it will going to check what is maximum, minimum is, it will going to give you nothing but what exactly I'm talking about here. See here everybody, what exactly I'm talking is, so this will going to execute constant time, big O of 1. That's it. Okay, now here also, how many times you will going to do the division? Only one time, that's why. Here also same thing, big O of 1. But here, okay, you are dividing array one time, that is also okay. Again, you will going to divide if the array is still big. So this way you can able to see left side is still big, it will going to be divided once again. That is the reason why here array will be array having n number of elements, divide by 2, nothing but what happens here, n by 2 times. Here also n by 2, nothing but totally t of n by 2, totally t of n by 2. That's it. So totally what you will going to get it, 2 t of n by 2, right? That's it. Again, this is actually what we are doing here we are doing, what is that? Here we are doing conquer we are doing here, conquer we are doing here, we are doing divide requires one comparison, divide requires constant time. Okay, so for this we know we don't want any constant time, it takes some time. So that is the reason why 2 t n by 2. But here combine, see here, come to the combine. Here also to combine how many comparison, one comparison more than enough. That is the reason why it takes constant time here. So that is the reason why big O of 1 over. That's it. Okay, so let's go to the next page and see what we are doing here now. So let t of n, let t of n, t of n, that is equal to time complexity of this particular algorithm. For this particular algorithm, we are what we are writing? We are writing recurrence relation. Please understand, we are writing time complexity. Okay, recurrence relation we are writing. That is what exactly I told you already. Big O of 1. Okay, if n value is equal to 1 or n value is equal to 2. Okay, either you can write like this also. See here, either you can write like this also, otherwise there is another way. Okay, otherwise there is another way, not worry. Like this, n is less than or equal to, this is also okay, no problem. Otherwise, okay, otherwise no problem, otherwise write like this. What is that? 0 is less than or equal to, okay, sorry, 0 less than, 0 less than n are less than or equal to 2. This is what exactly, like this also you can able to write. And we have seen that, yes or not? We have seen that. See, big O of 1, here also big O of 1, here also big O of 1, here 2tn by 2. Okay, so now I will going to take the function here, big O of 1. So again, because it's a constant one, that is the reason why here I will going to take it t n by 2 plus t n by 2. Here you are having problem, right? Somebody having problem here, how to take this one. So that is the reason why I written this one. Everybody observe here, that is the reason why I have written this one. Big O of 1 here as well as here combine. When you are doing the combine also, it is taking big O of 1. When you are dividing, it is taking big O of 1. Already I taken this one, you can able to see here. Please see here, observe here, big O of 1 already I have taken here. Here when you are dividing, when you are combining, this one. Again, when you will going to do all these things, if n value is greater than 2. Okay, this is the condition. If n value is greater than 2, you will going to do this. Totally what we will going to get, t of n, that is equal to 2 t n by 2. Same thing, that is what exactly I'm taking, 2 t n by 2 plus c constant over. You can ask me what happened to this one, sir? Big O of 1 as well as big O of 1, basically both are constant here, so that's why I taken c. That's it. Anyone have problem, guys? Anyone have problem here? Hello, anyone have problem? No, right? Chetan, problem now? Okay na, Chetan? Chetan, artha aitu pa. Anwar, any problem, Anwar? No, right? Okay, fine. Fine, no problem then. So this is how we will going to write the recurrence relation I have written. But today I did substitution method also, right? So let me finish that also, don't worry. So this is how you will going to write the recurrence relation. Very simple, I did it very clearly. T of n, that is equal to, okay, why I have taken this one? Because the reason is we have written for, this is for terminating statement. This is for what? Terminating statement. This is terminating. Okay, again this is for what? Else part. For else part I written this one. Where it for division, again for this one combine, for this one recursion. Okay, nothing but two sub problems are there. Size of the sub problem is 2. That's what. Okay, this is our master theorem actually. Okay, it satisfies our master theorem. Yes or not? Master theorem. Okay, that is fine. Now see here, we will go to the substitution method. Everybody see here. Okay, now, so what we will going to do, you can use the recursion, you can use the master theorem also for finding a time complexity. Otherwise you can use this one also. What is that? Substitution method also. What I will going to do, because I wanted to prove it, that is the reason why I will going to use the substitution method. Just you see here, see this t of n. Guys, if you have any problem, please look at this, because after that I will going to do the same thing for comparison, not for this. Later we will going to discuss about linear search. I will going to give you something different about linear search. Okay, after that we will wind up. Okay, now Tn is equal to 2t. Okay, n by 2, same thing, whatever the things we have got, that one I am taking plus constant. So what I'm doing, using recurrence relation, okay, substitution method I am applying on this particular recurrence relation. Okay, so what I will going to get it, t of n. So we have a one recurrence relation. Okay, one recursion is available here. Sub problem, two sub problems are there. This is actually a recursion right now. Now what I will going to do, I will going to take this n by 2. See here, everybody. Chetan getting, Chetan now. Chetan getting, please observe. Jitu, understanding. Hello. Anwar, Ashwini.
Yes, sir.
Okay. So what I'm doing, take n by 2. In place of n value, you apply n by 2. Okay, n by 2 is there right now here, right? In place of n by 2, substitute n by 2. That is what exactly I did it. Okay, what happens? Again, it will going to do the recursion as the recursion, right? That is the reason why 2 into, please observe here, 2 into, okay, 2t. Yes or not? Recursion is happening, 2t. And if I apply n by 2, n by 2, what happens? N by 2 square it will come. Correct? N by 2 square plus c. Again outside one more plus c over. That's it. Okay, now that's it. Nothing else. It's very simple actually. Now see here. Again after that. What happens? Now multiply 2 square to the power of 2. Okay. Because 2 into 2, 4. Okay. T now n by 2 whole square. Okay, now plus 2 into 2c plus c. That's it. So this is second level. This is second level. This is first level. Correct? Correct or not? This is second level, first level. Let's finish the third level also. Don't worry. Now see here, everybody. Again apply n value n by 2. Okay, now what happens here? Now everybody see here. 2 square I will going to keep it like that only. 2 square I will going to keep it like that only. Again into 2t. Okay, n by 2. What happens here? Whole cube plus. Yes or not? Correct? Correct or not? Again plus c over. That's it. Again 2c plus c. Now substitute here. Multiply. 2 into 2, 4. Nothing but what? 2 to the power of 3. I can write like this. T. Again n by 2 whole cube. Okay. Plus c. What c? What kind of c this is? What kind of c, guys? What kind of c? Tell me. 2 square c. Here it is there na. 2 square c. Again. Okay. 2 square c. Again 2 power 1 c. I will take it. Again here just c is there. I will going to make it like that to get 1. What we will going to do? 2 power 0 c. Okay. That's it. So this is the 3 levels you have to do always. Third level. This one you know. Up to here okay. Everyone okay? Up to here okay everyone? Jitu okay na? Jitu okay?
Yes, sir.
Okay. Now we will going to do for k times. K times. This one is for k times. Okay. What we will going to do for k times? That is equal to, see here, that is equal to. So 2 power 3. Nothing but what happens? 2 to the power of k it will come. Yes or not? 2 power k. Let me change the color. 2 power k t. Okay now 2 power k t. Again see here, n divided by 2 power k. Clear? 2 power k plus. Okay. Again, so because we are applying k, that is the reason why recursion will going to happen n number of times, k times. So that is the reason why now 2 power k minus 1 into c. Okay, k minus 1 into c plus 2 power k minus 2 into c, like that it will goes on continuous or not. k minus 2, k minus 3, like that. Okay. Again, at one point of time, it will become 1. That's why 2 power 0, 6. That's it. This line okay? This line okay, everybody? This line okay na? Okay, fine. Fine. Okay, no problem. Now find the value of k. So this k value we need it, yes or not? So this k value we need it. So what we're going to do here? Just take this. Okay, this one. Take this one. N by 2 power k, that is equal to, take it 2. Because I have taken 2, that's why 2. Already I given the example. Take a little bit greater one. Compared to 1, you take it 2. Okay, now solve this one. What happens here? So n value is equal to, n is equal to 2 power k plus 1, because 2 into 2, that's why 2 power k plus 1. Apply log on both sides. Apply log on both sides. Then you will going to get the value log n, okay, that is equal to k plus 1. Correct? Correct or not? That is equal to k plus 1. You will going to get it. Finally, what you will going to get it? K is equal to log n 1. It will come this way, minus 1. This is the value you will going to get it. Okay. Fine. I think you people got this. Now we got the k value. K value is equal to log n minus 1. Now apply that one. Apply wherever k is there. Please apply wherever k is there. So that is equal to, now observe everyone. 2 power, what is that? Okay. 2 power k is there. Okay. Apply here. Everybody please apply. Here I missed 2. Okay. 2 k value. What is the k value? Log n base 2 minus 1. Write down log n base 2 minus 1. This is what you have to write it. Got it? Everybody got it? T of n by 2 power k. See here, n by 2 power k. What is that? 2. We got 2. That's why 2. Nothing but we got the constant. Okay, now nothing but what it says that very clearly we got the constant. Now in this, everybody observe here. In this, everybody observe here. C is the constant, right? Please remove that C. Okay, remove that C outside because it's a constant. Now what happens? So k minus 1, all these are all series. One series is going on. Minus 1, minus 2, minus 3, minus 4, 5, 6, like that it is going or not. So it will going to end at a positive value. That is the reason why what I will going to do. I will take like this. Okay, see here 2 power 0 plus 2 power 1. This is what exactly I am taking. Again 2 square plus 2 power log n base 2 minus 2. Okay, that's it. This is how I will do. Clear here? Everybody clear or not? Everybody clear? Everybody clear? Okay, fine. Now, anyway, this is a constant. Yes or not? Anyway, this is the constant. We know that one. This is a constant. Again, this is a series, GP series. So that's why what I will do now, right now. So that is equal to 2 power log n base 2 minus 1. Okay. Plus, okay, T of 2. Here it is there. We are missing that. Plus C into here. Actually, it's series, GP series. Please observe here. This is a GP series. So that's why 1 into nothing but R value. Okay, R into 2 log n by 2 minus 1. I told you n will go here, n will come here, it will become 1. 1 minus 1, it will become 0. Okay, so later I will tell you about that. Divide by 2 minus 1. That's it. Okay, now 2 minus 1. Fine now. So this one you see here, that is equal to now. So basically this one, what it will become? It will become n, because n will come here, again 2 will go here, it will become 1. That's why 2 power 0 1. Okay, n power 0 1 it will become, that's why n into big O of 1, nothing but this is a constant, correct or not, plus c into 2 log n base 2. Okay, 2 log n base 2. So we got this. I simplified this one. Okay, now what you will going to get it finally. So this is n by 2. Sorry, this one I missed here. N by 2. This is here also. This is log 2 n by 2. Okay, fine. N by 2 plus c dot n. So this is what exactly. That's what I told you. It will become 2 log 2 base 2 1. Again n it will come. So finally, what you will going to get the answer? The final time complexity is very simple. Big O of n. So this is what exactly. Either you can say like this also, or you can write big O of n square. You can write like this also, as well. Please observe here, as well. Omega of 1 also. Again, omega of n also. This is what exactly. Fine. Anybody have doubts? Hello, anyone have doubts? This is what exactly we have done. Okay. So in divide and conquer, please observe here, in divide and conquer, there is, please, these lines are important. In divide and conquer, in this program, in divide and conquer, there is no best case, worst case, as well as average case for maximum and minimum for this program. Okay, there is no such kind of thing. Okay, in this problem, there is no best case, worst case, average case, because always it takes one. Okay, n, sorry, always it will takes n. Anyone have problem? Hello, bolo, anyone have problem? Please let me know. So this is the small problem we have done, and we will do comparison on this. Basically on this only we will do the comparison. Same thing I will show you that one also. Okay,